Hello and welcome to another A-Level Computer Science video with me, Mr Goff, for MrGoff.com. This video will be focused on fixed point binary. If you are moving from right to left, column headings in binary halve each step you take. It stands to reason, therefore, that this pattern simply continues to the right of the decimal, with the first column being halves, then quarters, eighths, and sixteenths. These can just as easily be represented with decimal values as is shown here. So to represent a number such as 6.625, we would put a 1 in the fours column, a 1 in the twos column, a 1 in the halves column, and a 1 in the 0.125s column. The number of places to the left and right of the decimal place make a big difference to what numbers can be represented and what numbers are being represented. For instance, 0100 1010 could be 1 and 5/36 if we use 2 bits for the whole number part and 6 bits for the part, whereas if we're using 6 bits for the whole number and 2 bits for the part, that would be 18.5. You need to be able to calculate the correct denary equivalent of a binary number given how many bits of the binary number represent the whole number and how many bits represent part. We can also use 2's complement with fixed point binary. This is still the same where the most significant bit will be negative. So if we wanted to represent a number like minus 4.375, we would start by knowing it's got to be negative, so minus 8 is going to have a 1 under it. Then we're going to add back the other numbers, so putting a 1 in the 2's column means we're at minus 6, and then minus 5 with a 1, and then minus 4.5 when we put 1 in the 0.5's column, then we put something in the 0.125's column, and we're at minus 4.375. With 4 bits for the whole number and 4 bits for the part, the smallest number we could make in 2's complement fixed point binary would be minus 8. This would just be a 1 in the only negative column. The largest number we could make would be 7.9375. This involves putting a 1 in all the positive columns. The flip the bits method still works with numbers with a fractional part that are negative. If we take a look at the number negative 4.375, which we did earlier, we'll now try it with the flip the bits method. So we start by creating 4.375 as a positive number, which is 01000110. We now flip all the bits, so the zeros become 1s, the 1s become 0s, and we add 1 to the rightmost column. We now have 1011, 1010, which is exactly what we got when we did it the other way. That brings us to the end of this video on fixed point binary. Join me in the next video when I'll be having a look at floating point binary. Use the resources at MrGoff.com to help you revise computer science, and until next time, it's bye for now.